Hello, my name is William Burnett. I'm a teacher in Bedford County Public Schools, and today I want to take you through a little bit about using Desmos in your Algebra 1 classroom. This is an introduction, and possibly in the future I'll make more videos that go more in depth, but this is for the teacher that's beginning to use Desmos in their classroom, specifically in their Algebra 1 classroom. Although if you teach anything above Algebra 1, this video probably has something in it for you. Now, these videos were supported by the Secondary Math Professional Development Center at Radford with funding from the Virginia Department of Education through the Math and Science Partnership Grant Program. So, big thank you to them for help supporting these videos. Today's video is going to go over how to graph basic functions using sliders with those functions, tables in Desmos. We're going to look at some classroom activities that we can do with linear equations, graphing inequalities in Desmos, as well as some classroom activities with inequalities, systems of equations, and maybe if we have time, some systems of inequalities as well. So go on over and follow along with me on your computer. Go to desmos.com. And when we get to desmos.com, we're going to take a look in a minute about the classroom activities like I mentioned, and that's right here. But right now we're just going to go to our basic graphing calculator. So click on Start Graphing. And in my first video, just the introduction to Desmos, we went over all the tools here and a little bit about what we're going to do today. But I want to just focus mainly on what you might use in your algebra classroom. So most of the time when I get a question on this, it's just, how do I graph a basic function? So if we had something like y equals 1/2 x plus 4, how do we graph that? We can just type in that equation, y equals, and for the 1/2, I just type in 1 and then the /, which is right next to your right shift key there, and then 2. Now notice it automatically makes the fraction for me. Desmos is so intuitive to use. It's so easy to use. It's rare that I'm like, how do I type that in? Because it kind of just knows what you're wanting to type in. So 1/2 x, I think I said plus 4, and there we have our graph. And so students can type in their graphs. Sometimes I let my students, I don't give them answers to their homework. Sometimes I do. But I always tell them, you can always go look on Desmos and check your work and kind of, go finding the answers for yourself and play around with the equations to see what you get here. So don't forget we can change the color of these by just left clicking on this little circle over here, and we can change it to dashed lines, dotted lines. We can change the colors if you want a color that stands out better with your projector or is different from something else you have graphed there. So that's our basic way to graph it. We can also use functional notation. So we could say f of x is equal to 1/2 x plus 4. Now, I prefer the functional notation just because there's a lot more students can do with it. Notice I've got both of these right here graphed on top of each other. You can turn them on or turn them off just by left clicking on that little circle on the left there. But no, as I was saying, I like using the functional notation because later on we can evaluate that function pretty easily by saying, well, if that's the f of x, what is the f of 3? And they can see, hey, that's 5.5. And so it's just, start getting them used to functional notation and why we use it. We can also later on, if we type in a different equation, we can use the g of x now. And so we can talk about why do we call it f, why do we call it g, why would we have h of x later on. And as students start graphing more and more things on the same graph, they see that like, hey, it's helpful to name them different things. If we were to type in, f of x and give it a different function, we wouldn't be able to evaluate it here because we got 2 f of x's. So just getting them used to why we do functional notation and how it can be useful, I think this is a big help using Desmos for that purpose. So try to, I understand you got to do y equals. They need to know, the basics there. But as they develop and start to use that functional notation, I think they'll, start to understand more and more why it's important to use functional notation. Now, while we're talking about graphing just your basic lines, let's clear this out and go back to our y equals 1/2 x plus 4. One of the things I like about Desmos is students can quickly play around with the different variables and see how they affect the function. So instead of saying 1/2 x right here, I'm going to make that just, we can actually use m since we use m so much in y equals mx plus b, and I can make m a slider. So here it says add a slider. So there we go, there's m is equal to 1, and now I can change my slope just by dragging that slider right there. And so you can start to have the open class discussion there is, what happens when my slope gets really, really large? When m is really large, how would you describe what's going on in the graph here? What about when m is 0? What do you think is going to happen there? As it gets closer and closer, as m gets smaller and smaller and hits 0, what happens? Oh, it's completely horizontal. What about if I keep dragging it to the left and make it negative? What's going to happen? So it opens up a lot of classroom discussion, and they can quickly see what's going on there. So it's not like you're just going to change the slope manually. You can just quickly slide it back and forth. Now you can change things about this slider right here just by clicking on one of the numbers, and you can make it go from -5 to 5,000 if you want, or I'm not going to go that far up. I'm going to go to 20. You can make it count by 1, so there it's going to go -5, -4, -3, and so forth. And so depending on your situation, you can change it to any incremental increase that you want there. And so not only do we have a slider that you can put in for m, you can also change this right here to b. See how it says add a slider? We can add a slider there. And now we can also change the y-intercept. And so here we can start talking to students about what's going on. Is this it's a good question, I think, is this a left and right shift in my line, or is it an up and down shift? And so with all these things, you can do it as a classroom discussion, or you could even just give the students a set of instructions and say, go to Desmos, graph these things, and write down your answers. There's also going to be some activities here we're going to look at where the students can type in their feedback. And really what I like to do with my students is encourage some mathematical discussion. Get them using vocabulary words. Get them thinking about the math, not just a procedure where this is my y-intercept, this is my slope, this is how I graph a line. Those things are important, but if they can have some good quality discussion, they're going to remember this information for a much longer period. Now, if you go back to Desmos.com, you can open up a new tab to do this if you want. Go to where it says teacher.desmos.com. You could type that in, or you could just go to Desmos and click on this, and it's going to open up some activities here. Now, as you do this, I recommend you sign in. So I just sign in using my Google account. That's what our school system uses. And then this way, as I go through and just looking at all the different activities here, if I like an activity, I can just click on this little bookmark right here, and it will bookmark it. So, we're not even talking about advanced quadrilaterals right now, but maybe it just catches my eye. It's the pick of the week or whatever. And I say, hey, that looks really cool. I'm going to come back to that later on when we talk about quadrilaterals in my class. So I can bookmark it. And when I do that, over here on the left where it says your activities, I can click on bookmarked, and it will be somewhere in this long list I have here. Somewhere now, probably at the bottom. There it is. And so you can go through, browse when you have time, and add activities that you think will be good for your class later on. But right now I don't have anything in here for linear, so let's just look up here at search, and I'm going to click on, I've actually typed it in earlier when I was planning this video. Click on linear, or you can type in linear if it's not already in there, and you've got a whole bunch of options here that you can use for linear activities in your classroom. So scrolling down, linear just kind of brings up a bunch of different things. It brings up systems of equations. It brings up systems of inequalities. So a lot of different things there. So you got to kind of scroll through or be a little more descriptive with your search. But just finding this one right here, this is Match My Line. So if you read the description, this activity, students will work through a series of scaffold linear graphing challenges to develop proficiency in direct variation, slope-intercept, point slope, and other linear function forms. This seems like something kind of like what we just did with graphing, or at least related to it. So if you click on that, it gives you a little bit more description to it. This is part of a bundle. So there's 7 other activities that are related to it. It's one of those 7 activities. And if you scroll down further, you can see a student preview. So if you want to know what the student sees, these are all the problems, by the way. There are 15 here. But if you want to see the student's view, you can click on that. And you can even interact with it like a student might. So let's see. Adjust the equation so that the line passes through the points. So it gives you teacher tips here for sample answers, and you see what the student sees right there. They got to submit it to the teacher, but they can adjust this however they see fit so that it will go through a set of points given there. Let's see if we can see those points. So here's one of the points, here's the other. So this is what a slope of rise 2, run 4. So they're going to need to see 1/2, and probably 2/4 would work as well. And as a class, you can discuss like why are these the same, or 0.5, or how you want the student to answer it. Oops. And so it just kind of, and then they submit it to the teacher to go on to the next one. So you can see what they're seeing here, or what they'll be facing when you assign this. Now, to assign it, you're going to go up here and you're going to create a class code. So when you create the class code, there's your class code. The students will go to, let's see, student.desmos.com. And so this is what shows up on your screen, and you can just project that so the students can follow that, type in the code, and then work from there. So just to see what it looks like on the student's end, if you go to student.desmos.com, I've created a fictional student here, Tobias, and he's going to enter his class code in. So it's YYG K9U. And they can change their name if they want to, but we've got it. I've already got like a made-up name there for him to go with. And this is what it looks like completely on the student's view there. So we'll do a few things. Let's see. This is the one we did a second ago where we've got to match that. So the slope was 1/2. Submit to the teacher. Next question. We've got to, let's see, plot 6 lines. Each should pass through the origin, and one of the 6 points, one is done for you, so we've got to create the other lines there. So if we have something like, let's see here, y equals 5x, y equals 1/3 x. And so these are pretty intuitive for the students to type out. Hopefully, if not, you can help them out. Y equals -2/3 x. So I just type in -2/3, and then I arrow over for that x there, and so forth. Let's go ahead and, just to save time, let's check my work, and it graphs those lines for me. So we can already see that, hey, my 5x is wrong. And I don't know if they've got a way to highlight that one. It doesn't, that I'm aware of. It graphs them in order there. So now the student can go back and say, hey, I got that one incorrect. Let's see, what can we do to change that? So 5/3, and now check my work, and they can say, oh, now it goes through. So it's a nice self-check there, so if they get it wrong, they can go through and adjust it until they do get it right. And so there's a lot of different questions here. I'll let you go through those, but I want to show you what it looks like exactly as a student, what they see, and then let's take a look at what we're going to see on the teacher's end of this. So on the teacher's end of things, this is that same page I was at. It shows up in real time what the students are doing. Obviously I only got one student here. There'd be more if it were an actual classroom. And you can quickly see what questions they've answered and what they have answered. So looking at this one right here, they've got an X on it because the student didn't finish graphing the lines. But I can see exactly what the student did right here. If there were more students, I'd see more, like a whole chart of everybody that's answered these questions. And so we go back and look and see this was Tobias's answer right here for question number 2. And so with more students, we'd see more answers here. In fact, if I want to post these answers for my whole class to see, and I don't want to show off like, hey, this is Tobias, this is what he got wrong or right, I can change the names just by clicking on this little circle up here. And notice it gives it a random name that's not one of my students in my class. And so you can share it with the class and talk about answers without particularly singling out a student. Now, I'm going to show you one of my classes, just is a geometry class, the work we did. So let me pull that up. So I want to show you some real results, not just a fake student, but this is one of my classes. And what I've done here is I've changed all the names, so they're not, you don't know what these students' names are to protect their privacy. But we can see the results from, it was an activity on slopes of parallel and perpendicular lines. So I can quickly look and see there were, 15 questions here that they had to answer. And by looking at the summary, I can see which students answered which questions, which ones were left blank. I can click on one of the questions and see what each student's response was. And so it's a quick way for me to just look through here and see how the class is going. Now there are some tools in this that are helpful. For instance, let's find something that has a little bit more of a response to it that I want to see. So here's one where they say the slope of the purple line is -1/2. What's the slope of the blue line if you made it parallel? So if I found an interesting response that I wanted to highlight, like they are the same, I can take this little camera right here, and it's called like a snapshot tool. So it's a snapshot captured. And then if I scroll back up to the top, if you go to snapshots over here, I've got Gene Taylor here. This was their response. I can drag them over here and highlight this collection right here for discussion later on. So what I'm trying to say is, as we go through and look at all of our responses, you know how it is, you have a few students that either have really good points or they're something that maybe a lot of students get hung up on and you want to highlight that. You can keep it so that nobody knows which student answered that, but you can also share it with the rest of the class, an actual student response, and either offer them praise or encouragement or whatever you want to do from their responses there. So that's a nice little tool that you can use in these to generate classroom discussion. Now, one other thing we can do in here, if this were a currently working activity like we had earlier with the Match My Line, you can also go back to pacing, and you can actually pace out so the students aren't pacing themselves. You can say, all right, everybody work number 1. You can review what they did with number 1 and then send them to number 2 and so forth. So you can do it so that the students are self-paced through this, or you can lead and guide the students, one slide at a time, and you can be in control of the pace of what they're going through. So these activities, there's several different types. We looked at Match My Graph. There are other things that Desmos does, not just match, not just these fill-in-the-blank answers. And so I would encourage you to look through all of the activities to see what types you like for your class. So we talked about graphing lines. The other thing we can do is we can graph inequalities. So I always have my students graph, when we talk about inequalities, start off by graphing a line like x equals 3. So if you type in x equals 3, there's our line. And then I say, what if we change this to x is less than 3? What would that look like? So on this, we can actually highlight the equal sign and just change it to a less than sign. That's just hitting Shift and the comma button. And notice it shades it for us. So we have x is less than 3. It also changed our line to a dashed line because we're not including the line x equals 3 in our solution. And once again, you can zoom in and zoom out and see what all is going on there. We can change the color by left-clicking on it and highlighting the color we want to shade it with. And so you've got 6 different options there to shade with. We can change this to a less than or equal to sign by using the keyboard down here. So if you click on that Show Keypad, we don't have a direct button on our actual keypad on our physical keyboard, but down here below we see a less than or equal to, And if you select that now, it's going to make that line solid. So we can see that there. You can do other things besides, vertical lines like that. We could type in y is greater than or equal to negative 2x plus 4. And we see that's graphed there. So students can use this to graph inequalities as well. You can do systems of inequalities on here. Let's type in another one like y is less than 2. And let's change this shading so we can see the different shades here. I'm going to use red. And we can see our overlap here. Now if you really want to challenge your students, you can have them so that they shade in only the overlap. And so that's going to require a little bit more there. We have to set, once we graph these two out, we have to put some restrictions on them so that only the overlap is shaded. And so that's a little tricky, but I can show you how to do that. So before we do that, to give you a little bit of background, let's just talk about how we can put restrictions on domain and ranges. So suppose I have the f of x is equal to x squared. And I want to restrict it to just positive values for x. And let's suppose we want to talk about, inverses of functions or something. So what I'm going to do is I'm going to look at, if you look at your keyboard, to the right of the P button is a bracket button. And then you got the little squiggly bracket there. So hit shift, and I call it a squiggly bracket. There's probably a better name for it. I hit shift and then enter in a squiggly bracket. And then I put in my restriction. I want x to be positive numbers. So I'm going to say x is greater than 0, or you can put x is greater than or equal to 0 by using the keyboard there. And notice it only graphs the right half of that parabola there. Same thing if you want to put a restriction in on a y. If we want to keep y like less than 2, I can say, I might have to define y, change it to functional notation. Let's see. Not functional notation, but to change it to y. Let's do that. And so now y is less than 2. It only graphs that portion of it. So that's how we put restrictions on our graph, is using those squiggly brackets. I'm going to go back to what we just did. And notice what's shaded in blue, this top equation right here. I want to keep that less than 2. So I'm going to put in a squiggly bracket and say y is less than 2. And notice what it does there. It shades in over here just everything below 2. If I go back to the home screen here so we can see what's going on, it takes out that top half. And then same thing with the red. If I want to keep it above negative 2x plus 4, I'm going to put in a squiggly bracket and say y is, basically you're just typing in that equation right there, but for that inequality I'm going to type in y is greater than or equal to negative 2x plus 4. And now just our answer is shaded, not the combination of the two, but just the overlap there. And so that's something to make students start to think about how to put restrictions on things, and really challenges them to start restricting domains, ranges, and what that looks like, and typing it out in like a code or inequality, however you want to state that. And there are a few activities you can do on Desmos that I want to share with you with systems of inequalities. So if you go back to desmos.com, click on the classroom activities, and we're going to search here for systems of inequalities. And so this one right here brings up a polygraph. Now we didn't do a polygraph earlier, and I've already created a class code for this and set up a class. These are the task cards on it. Notice it doesn't really give you a student preview because this is the student preview. So the real thing is, what do they mean by polygraph activity? So if we go here and put in that class code I have, so Tobias is going to play along the game here, say OK. And so this is an example of what a polygraph is on Desmos, minus the math. So if you've ever played the game Guess Who, that's pretty much what it is, but with math activities. So I'm going to pick, I don't know, this guy right here. And so this is a fake partner. This is just teaching the student how to play the game. It says, is your person wearing a long sleeve shirt? No, he's not. So you eliminate the people with a long sleeve shirt. Then here's our next question. Is your person wearing glasses? Well, they are. So it eliminates the non-glass wearers. He's not wearing a striped shirt, so we're going to say no. He's not waving. So the other student is seeing the same screens and they're coming up with these questions on their own. No. And so they figured it out in 5 questions. So we want to know how many questions that works. And so it says we're going to pair you with a classmate. One will pick a graph. The other will try to discover it by asking yes or no questions. So we're doing the same thing now, except for not with actual cartoon figures here, but we're going to do it with graphs. So we're going to do the same thing. We're going to pick a graph out. Let's see, I'm going to pick out, I don't know, this graph right here. Or actually, let's see here. It says the partner's me, my actual name there. So William is set up to pick the graph. So let's see if we got William's graph here. Select a graph that is special. I'm logged into 2 accounts. So I don't know, it doesn't really matter. We'll pick this one. And so we're waiting on Tobias. They part me up with Tobias. They want to know what the question is. So switching back to Tobias's account, now we can ask something there. So you want to ask a yes or no question. So I want you to see, think about being a student. What question would you ask here? And it makes the vocabulary important, and also just makes them really think about what they're going to ask, because they got to do it as few questions as possible, and they have to use good math vocab. So as you walk around or as you see or view their answers, encourage them not just to say, their own vocab math, but try to encourage them to really learn math vocabulary as they do this. I'm taking too long to ask a question. So yes, I'm still here. So you could say, do the shaded regions overlap? And so that's what William should receive. And so there it is. There's his questions. And so looking at this, that's my graph. No, they don't overlap. And so you have the I don't know option. And you can reply with a question if you want to. I'm just going to say no because they don't overlap here. And so that gets sent back to Tobias. So this is Tobias's thing here. And he can say, okay, the ones that overlap are X'd out. He could have also asked, is there a solution? You can, depending on the level of your students, you can ask them lots of different things. So notice he's eliminated a lot just by asking that question. I kind of already knew what graph it was, so I knew the right question to ask too. But they play this game, and then they'll take turns going back and forth. But polygraph, that's the name of it. It's more than just inequalities. If you go to Desmos' website, click on Classroom Activities, and just browsing through, you can see there's a polygraph on hexagons. There's a polygraph on basic quadrilaterals. So there's a lot. If you like polygraphs, do that. And then, of course, they've got other types of activities there for students to work on. Now, if you really want to challenge your students with inequalities, I would suggest, at Desmos.com, scroll down a little bit further. They give staff picks, which are, changing every day. But they also have creative art, which is really cool. And they definitely have to use graphing and inequalities in that. So, for instance, this one right here, I'll wait for it to open up. There it is. So we have a character here. Looks like from a cartoon. I'm not for sure which cartoon. But this is actually all coded in using inequalities. And they've even organized it by the folder here, lips, eyes, bird, face, everything that they use to draw this thing out. So, for instance, if we look at the bird there, and I click on that down arrow, here's all the code for that bird. And they put restrictions on it, they shade it using inequalities, all of those things. I mean, that's quite a bit of code, but notice it's a very intricate design. You don't have to give them something that complicated unless you got a student that really enjoys doing that. Here's a little bit of an easier one. I think this is from Dora the Explorer, if I'm not mistaken. But you can see where they graph the circles right here, parabolas, ellipses, hyperbolas. They've got all those things in there, and it's nicely organized into folders. So it's a good way to challenge your students, and also maybe a little bit fun for some of them to get into. Now, one other thing before we leave that I want to talk to you about is creating Desmos tables. So inside of Desmos, the graphing calculator here, if you click on the plus symbol right here, we can add a table, and students can type in their tables if they want to. So 1, 2, 2, 3, 4. And so you can begin to see where it plots the points for you. You can do other things besides dots. You can click on that and change it to open circles, X's. You can make them lines and then change the lines to dashed lines or dotted lines through the points. You can change the color of it. You can click an option so that you can drag it later on. So you come over here and drag it up and down if you want to, that point on the line. Drag it left and right or anywhere you want. So that's creating that table inside of Desmos. The other thing I wanted to talk to you about was actually copying and pasting data from either Google Sheets or an Excel spreadsheet. Anywhere that you've got data listed out, you can copy and paste it directly into Desmos and create a table like that. So I went to the National Weather Service and looked up temperatures for Blacksburg in September of 2018. And so let's suppose we wanted to make a chart for this. So what I'm going to do is just highlight and select all of this data right here. I'll go up to, let's see if we can scroll down and still select it all. There we go. So this will take the whole month of September here. Now I can't just select the max and min temperature. That's what I really want to graph. And so I'm going to have to paste this first into a spreadsheet. So coming over to Google Sheets, I'm just going to paste that data in. I've got all 30 days there. And so a few things, I know my max temperature is here, my minimum temperature is here. I don't really care about the rest of this data. I'm just going to delete that. And I want my dates in a better order so Desmos understands how it's graphed better. So I just want it to be like September 1st, 2nd, 3rd, 4th, and so forth. So it should be able to pick up on the pattern here. I don't have to keep typing that out. If I just highlight it, click and drag it down, there it is. And so now this will be a little bit easier to paste into Desmos. So suppose that's your data collected. I got it off of a website. You can teach your students to do it that way, or you might have them doing an experiment and they're collecting the data and putting it into a spreadsheet. So if I go over to Desmos, if I just paste this in, so I'm just hitting Control V here to paste it in, notice it actually graphs it for me. It graphs all those dots and it puts all the data in. And so now we can even do a few other things here to make this look a little prettier. We can, if you want to connect a line going through it all, you can, so you can see it a little bit, visually better. And we talked about the other ways that we can change that. And so you can see max, maybe the max I'll make it red since it's going to be warmer than the minimum temperature. And I might change the minimum temperature to blue because it's going to be a little bit cooler. I turn that graph off by accident. Let me go back up and turn it back on by clicking on it. Make that line come back there. And so now you can compare max and min temperatures for each day in September. You can also do other things with this graph where you can change, if you click on graph settings over here on the right, you can change it so that, well, we don't have a negative day in September, so let's change our x-axis to start at 0, or you can start it at 1. I like to do -1 just so we can see the y-axis and its labels there. And we know there are 30 days in September. So change that to 30. Count by 1 day at a time. And you can do the same thing with the temperature too. You can maybe change it to increasing by steps of tens, or you can even do 5s if you want to, so you see your y-axis. We can see the temperature a little bit better there. You can create labels. So on the y-axis we can say that is temperature, and let's see a little bit more of the x-axis, and you can see it's labeled right there, temperature. And then the x-axis we can say September 2018, and even put Blacksburg in there. And so once again, like we talked about in other videos, you can still drag it around. That does change it, and we don't completely limit it to 30 there, but it's just the view that we have. The students can take screenshots of this, paste it into documents, those sorts of things. So, if they want to make a chart, they can quickly make a chart, and they have a lot of options there with the way they can display that data. It's also a good way to challenge them and say, what's the best way to display this data? Should we have our y-axis going way out? Can we really tell much with something like that? Or how to scale things and that sort of thing. So the usual things we teach our students, but now we just got some new tools to do it with. So I want to encourage you, as you do this, use Desmos in your algebra classroom. Don't just do it because it's going to be on the SOL test, but use it so that use it regularly so they're comfortable with it. That way, when they get to the SOL, that's one less thing they've got to worry about. This is a regular part of their math class, is using Desmos. But also use it to enhance your classroom. Do those activities. Encourage good vocabulary skills. Encourage thinking about how you're going to graph something, what the best parameters are for your graph. Use it to explore different types of variables in equations to see how it affects the graph that you're graphing. So hopefully this video is helpful, and if you have suggestions on future videos, be sure to send them my way. And thanks for watching.